So, when you think about a massive industrial plant, what pops into your head? Maybe those giant reactors or a super complex control room? Well, the real unsung hero, the thing that's literally the lifeblood of the whole operation, is something you might not even see, the industrial cooling system. And trust me, it's not there for comfort. It's the one thing preventing a total meltdown.
Loss of cooling. That's a phrase that should make every single operator snap to attention. A plant trip? That isn't just a minor inconvenience. It's a sudden, super costly shutdown. Production just stops, all the equipment is stressed out, and safety, it gets compromised. That's why understanding this system isn't just, useful. It's one of the most critical skills you can possibly have. Okay, so here's our game plan. We're going to talk about why cooling is so vital. Then we'll break down the difference between cooling and chilled water systems. We'll trace the whole anatomy of the loop, expose the silent threats that can cripple it, and finally, get into exactly how you should respond when it all goes wrong.
All right, let's start with a powerful way to think about this. Picture the entire plant as a living, breathing body. If that's the case, then the cooling system is its circulatory system. It's constantly working 24/7 to carry away all that excess heat and stop the whole operation from spiking a really dangerous fever.
Just think about all the heat that gets generated by exchangers, compressors, and pumps. Without some way to constantly pull that thermal energy away, temperatures would just skyrocket. That leads to equipment damage, unstable processes, and eventually a full shutdown. So to put it simply, reliable cooling is what keeps the lights on and keeps production running safely. Now, you've probably heard people talk about cooling water and chilled water, and it is absolutely crucial to know they are not the same thing, not at all. Sure, both systems remove heat, but they operate in totally different leagues, and they're designed for very different jobs. Let's break that down.
So on one side, you've got your workhorse, cooling water. This is the system that does all the heavy lifting, removing massive amounts of heat from your main process equipment. But then you have chilled water. Think of it more like a surgeon. It operates at much lower temperatures, and you use it when you need really precise, fine-tuned temperature control for things like sensitive electronics, HVAC systems, or very specific chemical reactions.
Okay, so let's actually trace the path of the water itself. We're going to focus on the cooling water system because, it's the most common and the biggest one out there. Let's follow its continuous journey right through the heart of the plant.
These are the main players you're going to be dealing with day to day. You've got the iconic cooling towers where all that heat gets released into the air, the powerful circulation pumps that are the muscle moving all that water around, the heat exchangers where the real magic, the actual cooling, happens, and then the whole network of headers and return lines that act just like the system's arteries and veins.
And this shows the whole cycle perfectly. So the pumps send cool water out to the plant. As it moves through all those heat exchangers, it soaks up process heat, kind of like a sponge. This now hot water flows all the way back to the cooling tower. Now inside the tower, evaporation is the secret ingredient. As some of that water evaporates, it carries a massive amount of heat away with it right into the atmosphere. The rest of the water, now nice and cool, collects at the bottom, ready to get pumped out and start the whole journey all over again. It's a constant loop.
Okay, so the system seems pretty straightforward, right? But lurking just beneath the surface, there are these constant, silent threats that can slowly and very sneakily degrade its performance. This is the battle every operator is fighting, whether they realize it or not. Let's go back to our circulatory system analogy for a second. What happens when plaque starts to build up in your arteries? Well, the flow gets restricted and your heart has to work way harder. The exact same thing happens inside your cooling water pipes.
So what are these things? Well, you're looking at the three main culprits. First up is scaling. Think of it like that hard water buildup you see at home. You'll notice its effects as slowly rising temperatures, even when the process load is the same. Next, you've got corrosion, where the system is literally rusting from the inside out. You can often spot this if you see weird colors in your water samples. And finally, biological growth. We're talking slime and algae that can choke off the flow. A classic giveaway for this one is a musty, earthy smell near the cooling tower. This is exactly why managing your water chemistry is a constant, high-stakes battle.
So, here's the bottom line. It's this simple. The health of your water is the health of your cooling system. If that water is dirty or full of scale or corrosive, you are losing cooling capacity. You're increasing your risk, and you are heading straight for trouble. It is a direct one-to-one relationship.
And this brings us to the most important part of this whole explainer. What do you actually do when the worst happens? When those alarms are blaring and temperatures are climbing, your actions in those first few minutes can make all the difference in the world.
This right here is your prime directive. It's your #1 rule. When you lose cooling, the plant is still generating heat. Your first job isn't to fix the cooling system, it's to stop adding fuel to the fire. You have to cut the heat load on the system, and you have to do it immediately.
So, what does that actually look like in practice? Well, first, you cut back your process rates. That reduces the heat being generated. Second, you triage. Figure out the most critical equipment that absolutely must have cooling and protect it first. Third, you communicate clearly and calmly to the control room and the utility department. And fourth, you pull out your plant's specific procedures for this and you follow them. Exactly. This is no time to start improvising.
I really want this quote to change your mindset. A high-temperature alarm on a cooling system isn't a warning that a problem might happen in the future. It is a notification that an emergency is already happening, right now. Your response has to be immediate and decisive. Never, ever, ever ignore a cooling alarm.
And so, I'll just leave you with this final thought. A well-maintained, properly monitored cooling system, it's a silent protector, quietly keeping the entire plant safe and productive. But a neglected one, that's a ticking clock, just waiting for the right conditions to cause a major upset. And the choice between those two, well, that often comes down to the vigilance and the professionalism of the operator.